do is to look at an example or two. Well, let me write something here such as 4x, right? 3x cubed. Well, let me make that 3x to the 4th power, say. Negative 2y to the 7th power, all right? And let me put in another example here, something such as 16z to the 5th power, all right? And each one of these is what we will call a monomial, all right? A monomial. That's a new word, M-O-N, monomial, all right? And as a matter of fact, in each case, notice that in this case we have a variable x. Here is also the variable x. Here's just one variable y and one variable z. So it's a monomial of one variable, all right? A monomial of one variable. Now, I think what I'd like to do is to write down a general form for this monomial of one variable. And let me use the letter A to refer to this number out front, which we'll give a name to in just a minute. And x to the nth power, all right? A times x to the nth power is the general case for any one of these. Would you all agree with that? In which the letter A here is called the coefficient, C-O-E-F-F-I-C-I-E-N-T, the coefficient. And as a matter of fact, that number can be any real number except what? What do you think it cannot be? What number can it not be, Ron? Except 0, because if this were 0, 0 times anything you know is 0, and hence we have no monomial to speak of. Is that right? Right? And this number n up here we refer to as the degree of the monomial. All right? And as a matter of fact, what we will do is to agree that this degree n is over the set of natural numbers. All right? The only kinds of numbers that we can have up here, at least for the time being, is a natural number. Later on, we might include, in fact, we will include other numbers for the exponent, for this degree. Okay? Now, let's look at these examples. And what's the coefficient of this first example, of this first monomial? And Chip says the numerical coefficient is 4, in this case, 10, 3, in this case, Mary Lou, negative 2, and in this case, Ron, 16. All right, that's the numerical coefficient for each of those examples. What's the degree of this first example here? Sally?
1.
The degree is 1. We could put a little 1 up there, but it is understood. As a matter of fact, in this case, let me put that number 1 up there. What's the degree of this one, Kirby? Of this example here? It's a 4, yes, fine, all right. And in this example, the degree, James says, is 7, and of course, in this example, Chuck,
5.
it is 5. Good. Now, there are two special cases that we have to consider. Perhaps one is even a little bit more special than the other. If I happen to have a number such as 6, all right, in a certain context, in the context in which we are talking about monomials, this is a monomial. It's a monomial. And 8, negative 3, 17 are all examples of monomials, all right? But the degree of this particular monomial is 0 degree, all right? So let me write in the word 0 degree. All right, if we have a constant, what we might think of as a constant here, just the variable, just the numerical coefficient a is what you're really looking at there, okay? The degree of that monomial is 0. Now, notice I did not write down one number. And what number did I not write down in this case here? Well, I haven't written down lots of numbers, but a special one probably might be 0. Now, if I write the number 0 down, you and I will agree that the degree here is undefined. This simply has no degree, okay? We don't assign any number to this number 0 for a degree, all right? Now notice this is a monomial in one variable, all right? And what I'd like to do is to look at another example. Oh, let me just make up some more examples. 4x squared y cubed. And now notice I have thrown in 2 variables in this example. Negative 3 x to the 4th, y to the 7th power, say. 16 x squared y to the fifth z to the sixth power. And as a matter of fact, here I have three variables in one case, all right? Now these are still monomials. They are still just one term there, a monomial. All right, so let me give this a name. This will be a monomial. And in this case, what? Instead of having one variable here, let's call these more than one variable. More than one variable. All right, these are examples of having more than one variable. Now, just as over here where I wrote down a general case of a times x to the nth power, over here let me write a general case. Well, let me decide to have a as a name for this numerical coefficient. Let me use the letter x again, raised to the n. Let me just use the case in which we have, say, two variables in here rather than 3 or 4, all right? This we will still call the numerical coefficient, or let me just write down the word coefficient, coefficient. And now, in this case, we have to be a little bit more careful about what we'll call the degree. And it's by an agreement again, all right? Let's agree that the degree of this monomial is going to be the sum of the degrees m plus n, all right? Or perhaps I should have written it n plus m. But since you and I had the commutative property yesterday, we know that they are equal. Is that right? All right? So the degree is the sum of the exponents. For example, well, let's look at the coefficient. In this case, what's our coefficient here, Chip? The first example is 4. What's its degree? 5. Good. In this example, Steve, what's the numerical coefficient first? -3, and its degree is 11. And in this third example here, the numerical coefficient, Brenda, is, and its degree is 13. Is that right? All right, everyone agree with that? Very good. Now, let me write another example, and perhaps, let me pick that first case, 4x squared y cubed. All right, now let's decide to write something like -3x squared y cubed. And let me decide to write 7x squared y cubed. And let me write a fourth one, 22x squared y cubed. And you look at these four monomials, right? Each one is a monomial. And the question is, what do you see that's in common with those four monomials? What's the same there, Chuck?
They all have the same degree.
They all have the same degree. Very good. And also, not only do they all have the same degree, but they are also, they all have the same variables. The same variables, right, and the same order. What's the one thing around? What's the one thing that's different? The one thing, Brenda, that's different? The coefficients, all right? Now, when we have monomials in which they are the same except for the coefficients, all right, there's a word that we use to describe those, and they are called similar monomials. S-I-M-I-L-A-R. Similar, or another word that people use is like. They are like monomials. All right? So I think you will agree with me that in this case, if we had to give a name to these, what would we call them? They are called what? If I had to write a word here to describe these four, the one trait that they all have in common is that they are what? Mary Lou? Of the same degree, yes, but in terms of these two words that I have just written here, similar or like, what shall we say, Ron? That they are like, all right? Like. And as a matter of fact, let's just put down an example. Well, here's an example up here in which if we had to give these a name, these would be called what, Brenda? Unlike. Unlike. Monomials. Is that right? Unlike monomials. Okay, that's good. Now, what I'd like to do is to, well, let's come back and look at another example. Let me write an example such as 4x squared. Now, from everything that we have written here on the board, I think you would agree that this is called a monomial in one variable. Is that right? Well, let me just then write the word monomial here. And out in front, M-O-N-O-M-I-A-L. That's a monomial. Is that right? Now, what I'd like to do is to take another monomial. Another monomial. Let me write this first one down here, 4x squared, plus, and let me just make up, negative 2xy. All right? And this one happens to have two variables in it, but that's all right. And what have I done? I've taken one monomial and a second monomial and added them. Is that right? And we give this one a special name because it happens to have two terms in it. We call that, Sally, a binomial. B-I-N-O-M-I-A-L. All right? A binomial. And then, in fact, we can take that one, 4x squared, plus a negative 2xy, plus, and let's just add something else, plus, let's say 6y squared. 6y squared. And I now have a string of three monomials added together. Is that right? Notice we have added them. In this case, we have added a negative 2 times xy, but that's all right. We have still added these monomials, and Bob says the name for this is a trinomial. T-R-I-N-O-M-I-A-L. Okay? Trinomial. I think we all know that mono means one, and bi means the Latin derivative for two, and tri is for three. Now, anything beyond three, we don't make up another special name for it. Let's write one down here. Such as 4x squared plus, I'll just repeat this, negative 2xy plus 6y squared, plus a negative 5 x squared, y squared. Let me write that one, right? What we normally do, now notice here I have four terms, right? And rather than making up some other word such as a quatrinomial or anything like that, we then start to generalize this, and we simply refer to it as, Brenda, a polynomial, P-O-L-Y-N-O-M-I-A-L, of, in this case, 4 what? We call each one of these a term. So this is a polynomial of 4 terms, all right? And as a matter of fact, if we had to give a name to this entire idea, let's call it polynomial, P-O-L-Y-N-O-M-I-A-L-S, all right? Now, a monomial is a special case of a polynomial. It's a polynomial of one term, all right, which we also call monomial. A binomial is a polynomial of 2 terms, which we give that special name called a binomial, all right? And similarly, here's a trinomial. It's a polynomial of 3 terms. Anything after that, if I happen to have 17 terms strung out here, all added together, all right, we would simply call that what? A polynomial of 17 terms, okay? Now, let's look at a polynomial and decide one other thing, all right? Suppose I took a polynomial, well, let's write one such as this, 4x squared plus a negative 2xy. Let's just take that trinomial there and repeat it, plus 6y squared, okay? Now notice each one of these terms is unlike. Is that right? It's unlike. As opposed to, if I were to write another example, 4x squared plus a negative 2xy plus 6x squared. In this case, are there any like terms that you see in there, Sally?
Yeah, the 4x squared
And the 6x squared, all right? Now, we're going to learn some other time, probably tomorrow, that in fact we can simplify this one a little bit. But we look at this one and we see all of the terms are unlike. Is that right? So as a matter of fact, let's just call that the simple form. The simple form, the most simple form of the polynomial, okay? The most simple form of a polynomial is when there are no like terms in it, all right? There's nothing more that I can combine, or I can't do anything more with it, and so we'll call that the simple form of the polynomial. So here's an example in which this is written in simple form, is that right? This is in simple form, and I think you would have to agree that this one is not in simple form. Let me put in the word form there. All right, form. Everyone agree? All right? And I think there's just one other idea that we should look at for today, and then I think, as a matter of fact, perhaps we can also look at the oral exercise and go through those before we go into the assignment. Okay? Now, let's take another example, and let me come back to, say, this example of this polynomial and with 4 terms in it, all right? There we have 4x squared plus a negative 2xy plus 6y squared plus a negative 5x squared y squared, all right? Now, the first question is this in simple form? So you look at each term and you look across the entire row here of terms at the entire polynomial, and you look for any terms that are like. So do you see any like terms in there? And Sally said?
Yes, the first one and the third one.
The first one and the third one, Sally says, are like terms. What do you think about that, Ron? They aren't. And why aren't they like terms? David?
Well, because one's x squared
and one's y squared. Okay, so what do you think we can say about this polynomial? Bob, is this written in simple form?
Well, I ain't sure. I think so, except the second one and the fourth one.
The second one and the fourth one. And this one has xy in it, and this one has x squared, y squared in it. So what can we say about that? Does that make them the same? Are they like terms, Chip?
No.
They're still not like terms. So what conclusion can we come to, Bob? It's in simple form. All right. Now, once we have a polynomial in simple form, then what we want to do is to decide on what we mean by the degree of that polynomial. All right? Now, the degree of a monomial, let's come back here, say, to the case in which we have a monomial with more than one variable in it. The degree of that monomial was the sum of the coefficients. All right? So you look at this example down here, and in this case, we simply have the one variable x. So what's the degree of the first term? 2. What's the degree of the second term? 2. What's the degree of the third term? 2. What's the degree of the fourth term? 4. Now, what we will decide, the agreement that we'll make, is that the degree of a polynomial is the degree of the highest term in that polynomial. Okay? The highest term in the polynomial. So what's the degree of that polynomial? Ron says 4. All right? So let me write the word in there. Degree of a polynomial. All right? The degree of the polynomial. And in this case, we'll say that the degree of this particular polynomial is 4. All right? How about this example up here? Now, here's a case, an example, which is in simple form. What's the degree of it? 2. Notice this one is of degree 2. This is of degree 2. This is of degree 2. So your conclusion is that the highest degree in there is 2. So that must be of degree 2. Very good. Now let's see. Here is a case that we have considered. All right. What about this case? That's the one that we have just looked at. That's also of degree 2. This would be of degree 2. Is that right, Kirby?
One question.
Yes.
Listed under the simple form of polynomial.
I'm sorry. Could you speak up a little bit?
Under the simple form of polynomial, you said the first term has a degree 2. Why does the second term have a degree 2?
Very good. Why does this term have degree 2 in it? Brenda?
Because the x in it is to the first degree and the y in it is to the first degree and y because y is to the
All right. And if you remember back here, when we had 2 variables, we added the exponents. And then the exponents here are understood to be 1, right, which we don't have to write, and 1 plus 1 is 2, which is still the degree. Okay? Good. Let's look then at some oral exercises. I think we have a few minutes. And let's turn over here to page 54. Jane?
I have a question like on the binomial and the polynomial.
Mm-hmm.
Like, do they have to be in some sort of operation, the two, like monomial and monomial? Like,
Mm-hmm.
do they have to be like an addition or subtraction, or can they just be like separated by a constant?
Oh, very good. And as a matter of fact, I thought I said somewhere along the line that a polynomial is derived from the sum of monomials. You just add up a lot of monomials, all right? It's the sum of those monomials rather than commas or anything else. We will not consider say 4x squared divided by 5y squared as a polynomial. All right? The sum of the polynomials. Good. I'm glad you brought that up. That's a very good question because that's our definition of a polynomial. The sum of monomials. And we'll learn later on, for example, right here, 4x squared plus a negative 2xy. Later on, we'll learn that we may write that in another form, slightly different form, but it's still the sum of the polynomial, of the monomial. Okay? Let's turn over here to page 54 and run through a few of these oral exercises. The directions at the top of the page say, in exercise 1 through 12, state whether the given expression is a monomial. They say yes, it's a monomial. If the expression is a monomial, give its coefficient and degree. So, in number 1, Steve, what can you say?
5, it is monomial. 5 coefficient and 3 is its degree.
Good. Number 3, let's just do the odd ones here. Sally?
It isn't a monomial.
It is not a monomial, Sally says. Ken, what do you think?
It is a monomial, and the coefficient is 3, and the degree is 6.
All right. Now, Sally, I think you might be confusing the fact that it has only, the first case had only one variable in it. That was a monomial of one variable, but a monomial can also have more than one variable in it, as in this case here. Okay? Number 5, 1 over x. Is this a monomial, Chip?
No,
No, it is not, because it must be of the form a times x to the n, where in fact n is going to be what? What did we say about the number n right here? The degree of n must be what kind of number n? A natural number, all right? And I don't see any natural number in this case. Number 7, negative 4r to the 7th times s. Dave?
It's monomial, and the coefficient is negative 4, and the degree is 8.
Its degree is 8. Everyone agree? All right. Let's jump down to some of the later ones. In exercises 13 through 20, identify each polynomial as a binomial, a trinomial, or as neither of these. Then give the coefficients of the polynomial. Notice it's plural, coefficient. And if the polynomial is in simple form, give its degree. So in number 13, what can you call that expression? Huh?
Trinomial.
Trinomial?
Coefficients are 7, 4, and 1.
And 1, very good. Now notice that 1 there. The coefficient of A there is 1. Good.
And its degree is 3.
Its degree is 3. Everyone agree with that? All right, the degree is 3 because of the 4a cubed. Brenda?
Never mind.
All right. Good. Those are the best kinds of questions to answer when you answer them yourself. Number 15. Mary Lou?
It's a binomial, and the coefficient is negative 1 and 1, and the degree is 4.
It's 4?
So 5.
It's 5, all right? That 1, x to the 1 power, is going to be a little confusing at the beginning, but you want to think of it, all right? It's 1 plus 4 there, which is a degree of 5. Number 17, Jane?
It's a trinomial, and the coefficients are 2, 4, and 6, and the degree is, it's not in simple form.
Oh ho, it's not in simple form, all right? So what conclusion must we come to then? Can you talk about its degree as written? All right, we don't have any method at the moment of saying what its degree is. Good. Number 19. Let's see, who hasn't had a chance to say much this morning? Dave. Yes. Number 19? What?
I'm not.
All right.
Its coefficients are...
Well, what do we call that creature, first of all?
Polynomial of 4 terms.
Good.
Its coefficients are 1, 3, 3, 1.
Good.
And degree 3.
Its degree is 3. Everyone agree? All right. Very good. Let me give you the homework assignment for tomorrow, for the next lesson, and I think, in fact, you can go on from there. Before I do so, however, let's look down on page 54 again. Sorry for those of you who are so quick. I want to make sure that the directions are perfectly clear to you. It says copy the polynomial in each of the exercises 1 through 18 and underline similar or like monomials in the same way. And so look at the example. The 3x squared y and the 2x squared y, you agree, are similar or like terms, so they put one underline there. And then the other two are also similar or like terms, and they put a wavy line. All right? I don't care what kind of a line you put under there, but whatever it is, have it the same for the like term. Is it clear? All right? And then in exercise 19 through 24, it says on page 55, provide exponents or coefficients to make a pair of like or similar monomials. So I think that's quite clear and you know what to do with those. Let me give you your assignment for lesson 12.